Welcome to A Journey to BSO. It's a paper presented at EMMSAD 2020, a wonderful conference on exploring modeling methods for systems analysis and development. For further information about the ideas expressed in this presentation, please go to the paper itself, published in the proceedings of the conference. In this paper, I'm going to be talking about ontologies. Specifically, the two ontologies developed based on the ideas of Mario Bunge, a philosopher and physicist. Ontologies play a key role in modern science and technology. For example, to fight diseases such as COVID-19, scientists frequently consult medical domain ontologies, which are information technology artifacts that contain concepts and the relationships among these concepts in their domain of interest. So for example, it would be an ontology that would be able to talk about how various concepts related to the viruses relate to the parts of the body which these viruses affect. By studying these ontologies, scientists hope to better understand the nature of, for example, COVID-19 and possibly find a cure. Ontologies are used widely in IT, including in conceptual modeling, search and retrieval, information integration, knowledge management, AI, just to name some applications. In this research, I am focusing on a domain ontology, as well as a general ontology. A domain ontology presents a description, often formal, of constructs in a particular domain. For example, in online auctions or consumer electronics or medical ontology of infectious diseases. However, a domain ontology, in order to create it, needs to be referencing basic constructs, basic notions, which come from a general or foundational ontology. General or foundational ontology is a branch of philosophy that studies what exists in reality. It offers IT theoretically grounded, consistent, formalized, and rigorous meaning for basic constructs that exist in reality. Due to their importance, numerous general ontologies have been developed. In this paper, I'm focusing on a prominent one, known as BWW, or Bunge, Wand, and Weber. This ontology was developed by Yair Wand and Ron Weber based on the ideas of the philosopher-physicist Mario Bunge. Let me give you an overview of this ontology. Imagine you are visiting Newfoundland and Labrador in Canada, and you're hiking on Cape St. Mary's. And what you would be seeing is a gannet colony of these unique birds, gannets. You could use BWW to describe this colony. BWW says that the world is made of things, which are substantial individuals and are unique. For example, this bird and other birds, as well as other things that you could observe, are things. Things interact with one another, leading to acquisition of new or loss of existing properties. And when the properties of things change, we could call these events. Sets of things form systems. Properties of things are not directly accessible to human observers, resulting in the notion of attributes. Attributes is what humans use to describe things. For example, we could use various attributes of this bird to describe some of its underlying properties. We could also apply the notion of things to the bird colony itself, and perhaps to the rocks and other things that are there. Applications of BWW have been numerous. To give you an example of one, in my own work, I used the ideas of BWW in order to develop better interfaces for crowdsourcing or citizen science systems. So suppose you are observing some bird out there. Using the ideas from BWW, I would reason that you would be observing a thing, and I would be asking you to describe what you've observed, the thing that you've observed using its attributes. Over the 30-year span of BWW, the ontology became a subject of heated debates. For example, some debated whether it had a narrow physicalist focus. Other researchers have criticized the ontology for the perceived lack of support for social phenomena, for example, and so forth. However, a key overlooked issue is that BWW is founded on an early subset of Bunge's ontology based on 2 volumes published in 1977 and 79. And since then, Bunge actually published an incredible 400 books and articles. The question then is, do more recent ideas expressed since 1979 call for a new ontology? That is there a sequel to BWW that may address some of these concerns and criticisms? In order to answer this question, I conducted a 5-year analysis and synthesis of Bunge's research. I started with a general review of publications. I had a privilege of meeting and corresponding with Mario Bunge himself, as well as I conducted a systematic review of publications, especially since 1979. All that was synthesized, and at times I had to reconcile some of the ideas into what I call Bunge's systemist ontology, a new ontology sequel to BWW. Let's begin understanding BSO. And we'll do that with the basic question, what is the world made of? Is it things? Well, as it turns out, over the years, Bunge has been re-evaluating this claim, leading to the new idea that the world is really made of systems. The notion of system has multiple advantages over the construct of things. For example, it is easier to use the notion of systems to describe a variety of phenomena such as forces or fields. Also, the notion of things does come with a little bit of materialistic physicalist baggage, whereas a notion of system is more neutral. And you could use this notion to describe a wider variety of phenomena a bit more naturally, including social phenomena as well, and mental. And finally, an important consideration is Bunge, in following recent advances in modern science, argues that it is possible that there are no simple structuralist entities out there, which he calls, therefore he calls all things that exist, potentially including the most primitive fundamental particles, systems. To illustrate, let's return to the bird colony. In this bird colony, we could use the notion of system to describe a variety of things that we are observing, including the colony of birds, various groups of birds, a particular bird. It is a system in that it is formed from other components such as cells, and the cells are formed from molecules, which are then in turn formed from atoms, and the atoms are formed from more elementary particles like protons and neutrons and electrons, etc. But we could also use the notion of a system to describe wind patterns and the sky and the ocean current and the waves, as well as the rocks and so forth. In BSO, systems are composed of other systems. So that gamete is composed of tissue, which is composed of cells, and then molecules, and etc., etc., etc. This is how we get from the fundamental underlying physical reality through chemical and biological, all the way to social, technological, and mental. Systems have properties, and a set of properties at a particular moment in time is called a state. This is exactly like in BWW. However, in BSO, systems are conceptual and concrete, and only concrete systems change. That is, they have events. Concrete systems are those systems that have energy. Another important addition to BSO is the CESM model, which is a model for formally describing any system. Let's use an example to understand how the model works. Suppose one of the systems we're interested in is the gannet colony. We could use the components of this colony to describe the subsystems it is made of. In this particular case, the gannets, young and old, male and female, are the subsystems of this system. We then describe the environment in which the gannet colony system exists. The environment is made of other systems with which the gannet colony interacts. So in this case, it's the ocean current, it's the climate as well as the fish in the ocean, and the cliffs and the mountains and the grass and the rock on which the colony resides. The structure of a system is the types of relationships among its subsystems, so that is gannets. So the types of relationships among gannets, that is the mating, the fighting, the courting, the feeding relationships. And finally, the mechanism is a process or dynamic aspect of the system. It describes patterns of interaction among the members of the colony. So for example, how does courting occur? What is the nature and how does it happen, the process of feeding, etc. In BWW as well as in BSO, we have the notions of classes and kinds. However, there is also a change compared to BWW, because now kinds are understood as classes with interrelated properties. This definition is closer to the more recent understanding of natural kinds by philosophers and psychologists. An important element of BSO is that it does not just end with things, properties, events, and laws. It also explicitly deals with mental, social, and technological realities, containing constructs such as phenomenon, fact, hypothesis, observation, as well as social facts, brute facts, social systems. And of especial interest to information technology field, Bunge has been developing notions specifically tailored to IT, such as signal, information, code, which are integrated into BSO and are derived from the fundamental claims about the existence of systems and their structure. In summary, BSO allows to model greater variety of phenomena with high precision and sophistication. With BSO, we're able to model the things we were able to model with BWW, such as individual gannets, but we could go beyond that and describe gannet colonies, winds, ocean currents, ideas, electrons, economy, COVID-19, social distancing, and finally the virtual EMMSAD this year using the notions from BSO. So I would like to welcome you to the endless world of possibilities of a new general foundational ontology called Bunge's systemist ontology. Thank you.